Welcome to Algebra 2, Section 1.1, Intro to Algebra 2. This is mostly going to be review of stuff you've already done. All of the definitions are already put into Quizlet, so be sure to review that and be familiar with them. We're going to start on Practice 1.1. First part's wanting us to simplify each expression using the order of operations. We've got 3 squared plus 27 over 4 minus 8. Plus 8 times 1/2. So it'll take a few steps here. The numerator, I'm going to do the order of operations individually. The denominator, I'm going to do the order of operations individually, and then the rest of it. So I know 3 squared is 9. Everything else will just carry with it. 4 minus 8 is negative 4. Plus 8 times 1/2 is 4. Next step, 9 plus 27 is 36 over negative 4 plus 4. 36 divided by negative 4 is negative 9 plus 4, and that is equal to negative 5. This is pretty much how I expect your homework and your tests to look. It's a logical order, easy to follow, allows me to try to give you partial credit if you make a mistake somewhere. Number 12, this one wants you to identify the algebraic property used to manipulate each expression. All of those are in that Quizlet. You'll also find them in the chapter. It's given us g times 1 over g equals 1. It wants to know one algebraic property that is using. It's using the inverse property of multiplication. No real work there to do, just be familiar with those properties. Number 16, x times 1 equals x. That property is going to be the identity property. Of multiplication. Okay. Number 22 is asking us to rewrite the following expressions using the identified property. It gave us the problem of Q times the quantity of RT. Wants us to rewrite it using the associative property of multiplication. The associative property says that we can regroup anything in multiplication. So Q times the quantity of RT is also equal to the quantity of QR times T. Alright, we're going to go to number 28. It wants us to simplify using the exponent properties. So we just got to remember, when you multiply the bases, what happens to the exponents? When you divide the bases, what happens to the exponents? Number 28 says m to the 6th n squared times m to the 4th n to the 3rd. So we're multiplying the bases. So that's going to be, when we multiply the bases, we add the exponents. So we're looking at m to the 6th plus 4 n squared plus 3, which gives us m to the 10th n to the 5th. Number 32, when you raise an exponent to an exponent, we multiply those. we have the base of this, which is really important to recognize. The base of that exponent is everything inside the parentheses here. So that's going to distribute to each one of these. It's going to distribute to this, 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 and that one. So it's going to become 3 to the 4th, x to the 3rd to the 4th, y squared to the 4th, z to the 4th. Now we need to clean that up a little bit. 3 to the 4th is 3 times 3 times 3 times 3, which is 81. And then x to the 3rd to the 4th, you multiply those exponents. 3 times 4 is 12. X to the 12th. Y squared to the 4th, you multiply. Y to the 8th. Z to the 4th. Alright, again, just pretty straightforward logical explanation whenever we write it out neatly. Number 40, we've got 12 x squared z cubed over 4 x to the 5th z squared. When we simplify that one, 12 divided by 4 is going to be 3 x squared over x to the 5th. And better yet, let's redo this one. We'll add some extra steps just so that we're explaining it really well here. Okay, so that is equal to 12 over 4 times x squared x to the 5th times z cubed over z squared. 12 divided by 4 is equal to 3 over 1. X squared over x to the 5th. I'm going to pull that 2 down. Whichever exponent is smaller is going to cross the bracket and be subtracted from the other. So we're going to have x squared minus 2 over x to the 5th minus 2 times, the one on bottom is smaller on this next one, so we're going to subtract it. We're going to have z to the 3rd over z squared. We'll subtract 2, subtract 2. So now we've got 3 over 1 times x to the 0 over x to the 3rd times z to the 1st over z to the 0. That becomes a 1. That becomes a 1, leaving me with 3z, I don't need to show that 1, it's understood, over x to the 3rd. You won't have to show as many steps as I did there, but I want you to see it, why it works. Okay, number 42. The quantity of AB to the 0. It's really important again, that exponent, the base of it is everything in those parentheses. Anything to the 0 power is equal to 1. Okay, number 48 says to write without negative exponents and simplify when necessary. So it doesn't want any negative exponents, which means we need to take them to the opposite side of the fraction to get rid of them. So the top is going to be 5. That's going to drop. That's going to drop. The bottom will be 3. That one stays. V squared. That one goes up. So that becomes y to the 3rd up here. Now these two I'm going to drop. D to the 4th. F to the 3rd. 54. It's a little bit different. It wants us to write without denominators and simplify when necessary. So this one, looking at it, it wants us to get rid of all of this denominator. The only way we can do that is to bring these variables up, which means we're going to have to give them, when they cross that fraction bar, they're going to become negative exponents. So 15 divided by 3 is 5. We've got d to the third, f to the fourth. Now that comes up as h to the negative sixth. That one comes up as k to the negative fifth. So those two things are exactly the same thing. One's rational or written as a fraction. The other one has no denominator. Okay, number 60 wants us to translate each word phrase into an algebraic expression or relation. So the sum of 8 and 3, key words are mainly the sum, 8, 3. We know we're going to use those. The sum of 8 and 3 is simply 8 plus 3. Y is greater than or equal to 0. Just like it says, y is greater than or equal to 0. Number 72 wants us to evaluate the expression at each value. So there's two different problems here. On A, n is equal to 2. B, n is equal to negative 2. One thing that you'll see I do all of the time is when I substitute, I'm going to put the variable in parentheses so I can keep up with it. So I know it's going to be 7. I'm replacing n with 2 times, I'm replacing n, can't replace it. I'm replacing n with 2 minus 8 minus 5. So now I get 7 times 2 is 14 times, I've got to do my order of operations. 2 squared is 4 minus 8 minus 5. 14 times 4 minus 8 is negative 4 minus 5. 14 times negative 4, so 1428, negative 56 minus 5, negative 61. On B, I'm going to replace n with negative 2. So I'm going to have 7 times negative 2 times negative 2 squared minus 8 minus 5. 7 times negative 2 is negative 14 times order of operations. Again, negative 2 squared is positive 4 minus 8 minus 5. Negative 14 times 4 minus 8 is negative 4 minus 5. Negative 14 times negative 4 is positive 56 minus 5 is positive 51. Easy to get lost in those if you don't use those sets of parentheses for your variables, especially with those negatives.